Good day, guys. We want to handle another problem by completing the square technique. So it's the integral of dx on the square root of negative 2x squared plus 3x plus 6. So I always start by advising my students to go to page 4 of their formula sheet, search for a possible formula that resembles the problem you see when you're completing the square. So considering the fact that this problem is a fraction with the square root at the denominator, I'll go to page 4, search for possible formulas. So here's my formula sheet. Looking through my formula sheet, the first possible formula I see with a square root has a squared minus b squared x squared. That's the first possible formula, which is equal to 1 on b, the arc sine of bx over a plus c. So you see it's a formula that can handle that problem because it's a fraction with a square root of the denominator, just like the problem is saying. Then the second possible formula that I also see on page 4 of my formula sheet says the integral of dx on the square root of b squared x squared plus a negative a squared, which is equal to 1 on b, the ln of, in the square bracket, we put bx plus the square root of b squared x squared plus a negative a squared plus the bracket plus c. So the second formula is actually made up of two formulas that have been merged because the problem can be written with only a positive sign, where you see plus negative, or with a negative sign. So in other words, with this kind of problem for a mathematics the student, there are 3 possible formulas, even though these 2 are written as one. So now that we've picked our possible formulas, it's now the time to complete this one. So our procedure is always the same. You pick the quadratic and arrange it in order. Luckily, it's already arranged. So again, my negative 2x squared plus 3x plus 6, which is an expression. So you can see it's not equated to 0. So the first step of completing the square is to take out the coefficient of x squared as a common factor from every term. The coefficient of x squared is negative 2. We take it as a common factor from every term. So this is how it is done. You write your negative 2, then you open a square bracket, then you take the first term, you divide by negative 2, that will give you x squared. You take the second term, you divide by negative 2. That will give you negative 3 over 2x. You take 6, you divide by negative 2. That should give you negative 3. So that's my first step of completing the square of an expression. Then I can now move on to complete the square of the quadratic inside the square bracket. So that means I'll write my negative 2 there. Then the quadratic term must be written exactly the way you see it, followed by the linear term. Then to complete the square, we always take half the coefficient of x. You see the coefficient of x in the square bracket is negative 3 over 2. So half of negative 3 over 2 will give us negative 3 over 4. Then you square that number, you add it and subtract it. So I'm going to add negative 3 over 4 squared, then I subtract negative 3 over 4 squared before I write my constant term. So once that is done, then we'll say you've succeeded to complete the square. But that square you've completed is usually hidden in the first 3 terms in the square bracket. So those first 3 terms contain the complete square. So if I wanted to write down that complete square, I look at the first 3 terms in the square bracket. I only write the 2 in squares. That means I'm only writing x, and I'm writing negative 3 over 4. Then if I cover this with a square, then that gives me my complete square, which means this item here is the same thing as the 3 items there, because when you complete the square, you change these 3 terms to 2. You expand this by taking x minus 3 over 4 multiplied by x minus 3 over 4, take your time, it must return you up there. So now that we've seen the complete square, whatever is left, starting from the negative sign here to the end, you need to capture it in the calculator. So if you use a calculator, this will be 9 over 16, so that will be negative 9 over 16 minus 3. So you get negative 3 minus 9 over 16 on your calculator by 9, I get negative 57 over 16. So I have negative 57 on 16. So that is it up to so far. Now we go to the important stage, the stage that will help us to make a decision between these two formulas. At that stage, we need to allow the constant, sorry, when a mistake here, this constant should be negative 2. So I need to allow the constant to get into the square bracket. While it is getting in, I should fix my eyes on these two to see which arrangement will pick. So considering the fact that this number is negative, you see that if you get into multiply the first term, since the square is complete, it will stay out as negative. And that is a problem for the second formula because the second formula brings x first, but the number must be positive. So this is already rejecting the second formula that you can't work with the second formula because if this number goes in and stays there, it should be a positive number. If this was a positive 2, then when I open the bracket, this would be a perfect match for the second formula. Because it's negative, it means if I open my bracket, this negative 2 must multiply with negative 57 over 16 and become positive, and you move in front to match the first formula. Then when the negative 2 comes here, this term becomes negative, then goes behind. So I'll open the bracket. This side, if I open the bracket, then I'll be having negative 2 times negative 57 over 16, that will become positive 57 over 8, then minus, because this negative 2 cannot penetrate there, because that square is complete, it will stay out as negative 2 in bracket x minus 3 over 4 over that square. So that is how we complete the square. So as I always tell you, there is a formula for people who are struggling with completing the square technique. So if you can memorize this formula, it will help you. But the danger here is make sure you are good with memorizing. So once you substitute your a as negative 2, b as 3, c as 6 into this formula, it must take you there. It must take you to that level. So I don't think I will have to bother you doing that again because it's just for you to substitute a as negative 2, b as 3, c as 6. It must take you there. So that is it. So now that we've arrived here, and this looks like a perfect match for this one, it therefore means that we are matching this term to a squared, followed by a negative sign, matching 2 to b squared, and x will be replacing x minus 3 over 2. So therefore, if a squared is equal to 57 on 8, that will mean a should be root 57 over 8, and if b squared is matching 2, then this means b should be root 2, and you see it's important to do that because we need a and b on the right hand side. So finally, usually to be on the safe side, I always like to go and recopy the formula I've settled for between the two. I've ended up settling for the first one, so I'll copy it down exactly the way I see it on my formula sheet. Then I'll just replace my a, b, and x from left to right of the formula. So this is the arcsine of bx over a plus c. So if I can go through this formula, all I need to do is to see that dx remains dx as in the problem, in the denominator. Everywhere there is a squared, I'll put in 57 over 8. So I get 57 over 8, which is followed by a negative sign. Then where there is b squared, I'm putting 2. Where there is x, I'm putting x minus 3 over 4. Put my x minus 3 over 4. Then attach a square to that. Since my x here also has a square, then on the right side, I need 1 over b. My b is a simple root 2. Then the arcsine of bx, b again is root 2. Whenever I hear of x, I must use x minus 3 over 4, x minus 3 over 4, and this time on the right hand side there is no square there, then at the right 8, then plus c. So this is how easy it is to complete the square of this problem. And as I keep telling you, if they choose to put a number here like a 4, that 4 must not affect the way you complete the square, whether you're doing it this way, using that formula, it mustn't affect you. It only affects the final answer, where you come now after replacing all these things, you just put your 4 there, and whatever you do on the left, you do it on the right, and you're done. So guys, I hope that helps you.